Hello, everyone. So we have another problem from 2024 12B. So this was a number 23. So we have a right pyramid as a regular octagon base with each side is 1 unit and apex is V. And segment AV and DV are perpendicular. So we want to find the square of the height of the pyramid, right? Okay, so it's a 3D, we just like to make a visual. And then since we have a regular octagon, maybe I can use a circle to make that octagon. So let's try that. So let's say this is my circle, and I just want to make 8 points that's equally distance from each other. So let's say 2 points right here, and I'll need 4 on this, 3 on this side, 3 on this side. So that should be like 1, 2, 3. So that should be 1, 2, and 3. Okay, so it shouldn't be exactly accurate, but it's looks like fine. So if I connect these guys, the reason I just draw this inside of a circle because it's kind of good to see how we can get the interior angles or central, like the central angle or the inscribed angle, because that is really related to circles anyway. So which is why I just did that way. And that is my figure, right? So that's the octagon. And what we are told, this is the base, by the way. So I'm gonna say this is A, B, C, D, E, like F, G, and H. So we are told this is a regular octagon, okay, and then A to V, V is the apex, so which is not on this figure. So if I have like right middle point, like inside, right center of the octagon or center of the circle, and I have something like in 3D, and if I connect the top point to each vertices, that will make our figure. So, but for now, I'm just interested on the base of this regular octagon. Okay, so since we are interested A and D, so maybe I can connect A to D, right? So that will be A to D is this guy. And like this is symmetry because like what I mean by that, if I connect to H to E, the figure right here and the figure right here is the same because this is regular octagon. And like if you have like 8 like equally like space points, which means the distance between each one of these, like in terms of degree, is 360 minus divided by 8. So 360 over 8, so which is 45 degrees. So why do we care about this? Because if I take this central point and connect with, let's say, 2 points that is next to each other, E and D, the angle inside right here has to be my 45 degrees. So if this is 45 degrees, then I can just use this distance, like let me call this is O. This distance will be distance from that center point to each vertex will be same. So which is why this is isosceles triangle. So you can say this is like X and then this is X. So, and then we know that each side of the regular octagon is 1 unit. So that is gonna be 1. So at this point, if you really want to find the x, which we'll probably need it, we can use the log cosine. And if you do not know the log cosine, you can drop the height from E to like O to OD and make a 45, 45, 90 triangle and then use a Pythagoras on the right side. You can still go with that. But I will use the log cosine. But before I do that, um, I can even actually use 45, I mean 22.5 67.590 triangle, because when I like see this is 45 and the other two angles is isosceles, when you subtract this from 180, you got 135. Divide this by 2, you got 67.5, 67.5. So you can see that is the case, when you drop this height, so this 67.5, you will get 22.5 in this triangle. So that has also another special, like it's also another special right triangle. So if you like to, explore that as well, you may. But for now, we don't really need that in this problem. So, but anyway, so let's see what we are trying to do. So what we need is the square of the height of the premise. So we need to relate the height to this figure. So let me try to see if since this rectangle, right? Because how do I know this is rectangle? Because when you like think as each angle right here as inscribed angle on this circle, so that angle opposite to the sum of the two, arcs, sum of the two like arcs right here. So which is gonna be 90 degrees divided by 2 is 45. So this is also 45. And since we know the interior angle has to be 135 in that octagon, so because when you divide 360 by 8, you got 45, which is meant to be our exterior angle, as well as the central angle. Since exterior is just 45, then interior will be 135. So since this is 45, that will make 90. And the same reason with all other corners, so which is why this is actually gonna be a rectangle. Okay, so that means the center of the octagon, center of the circle will be the center of the rectangle. That is also center of that premise. So which is why if I want to make a kind of different figure and just kind of now try to see in this 3D. So let's say this is V, and then I'm gonna connect that into each vertex of that rectangle. So we can kind of see how to use that. So, this is the center. I'll take A right here. This is D, this is E, and this is H, right? So that should be H. So, and then that is V. So we are told A to V and V to D is perpendicular. So the angle right here in between these two is 90 degrees. And since this is like the point that is right on top of the center of the figure, then if you make that like A to V and V to D, that needs to be not just right triangle, it has to be isosceles right triangle. So A to V and V to D has to be equal. Okay, so that's why we can easily find those distances. But so what I'm gonna try, I'm gonna make a right triangle. So I'm gonna say we kind of know AD, even though I didn't find it, but I think it's time to try that. Because what we really need is the distance from the center to this point V, and then that is perpendicular to the base. So if I make the like somehow a triangle, so that will make like a good way to find our height. Okay, so that is H, which we are interested. And this is the half of the diagonal of the rectangle. So which is basically that X unit. So which looks like we need that distance for sure. But at the same time, we need AD as well. So let's go ahead and make some nice isosceles right triangle. If I drop this, and if I drop this in that base. So since we know this is one unit, the hypotenuse, and then this is 45, 45, 90 triangle, so that should be 1 over root 2. And then this is 1 over root 2. So this is 1 unit, so this is also 1. So this is 1 over root 2, 1 over root 2. If you look at the AD, so the AD is going to be 1 over root 2 plus 1 over root 2, which is 2 over root 2 plus 1, which will be just root 2 plus 1. So the AD is 1 plus root 2. Okay, so, and then DE is 1 unit, so that's something we know. But we remember that we need to use this information. So we are told these two are perpendicular to each other. So if I want to make like that segment, let's say this is gonna be let's say t, and then that will be t. So this is t, right triangle. So that's also 45, 45, 90. So t times root 2 has to be 1 plus root 2. So that will be t would be 1 plus root 2 over root 2. Okay, so t is this slant basically segment, slanted segment, which is gonna be this guy or that guy. So now we almost there because we know that t, if I know this guy, then I'll use a Pythagorean to find the h. But you know, we can find that x because that's gonna be same as this x. So if I use now log cosine or just dropping altitude with and then go from there with the Pythagorean and stuff. So you can do that, but log cosine is kind of easier. If I use the one as itself, so 1 square would be equal to the sum of the squares of the other two sides, which is x squared plus x squared, minus twice of the product of those two sides, which is x, times cosine 45. So if you don't remember the cosine 45, you can always go with the 45, 45, 90 triangle. So in this triangle, that is x root 2. So that means cosine will be x divided by x root 2, which is 1 over root 2 or root 2 over 2. So you can replace this with root 2 over 2. So cancel these guys. And then 1 equals, that is 2x squared. And then this is x squared times root 2. So minus x squared times root 2. And if I pull the x squared alone, so you will get 2 minus root 2 times x squared. If you divide both sides by that quantity, so you get x squared as 1 over 2 minus root 2. Okay, so for now, I'm going to leave as it is, and then I will simplify at the end. So we know the x squared, which is like this segment is x, so that's my center. And now if I want to use the Pythagorean, I think that should be giving us the final answer. So let's go ahead and do that. So the h squared plus a2o squared, which is x squared, which is this quantity. And I can even multiply this by like 2 plus root 2, 2 minus root 2 to make it rational denominator. So the numerator would be just 2 plus root 2 over, and if you multiply that, so that will be 4 minus 2, which is 2. So that is better now. And that is equal to square of the AV, which is, this was AV, right? And then if you square this numerator, so you will get square out by numerator again. So 1 plus 2 is 3. So you got 3 plus 2 root 2 over square of this will be 2. Okay, the h squared should be 3 plus 2 root 2. Since the denominator are the same, so we can just subtract this quantity. So 2 minus root 2 divided by 2. And 3 minus 2 will be 1. 2 root 2 minus root 2 will be just root 2. And then divide by 2. I think that is raised to. So this is not too challenging question, especially for number 23 on the 12th page. So fairly simple in my opinion. But at the same time, it wasn't really easy to get these points either, but the concept wise, we just use some basic geometry. So you can use vectors, I believe, in this problem, but I'm gonna leave that as it's a challenge for you to try. Anyway, I'll see you in the next video.